All right, here we will work on a problem which is instead of a free fall, it's you throwing a ball upwards with a speed of 25 meters per second. So there are multiple parts to this question. You don't have to worry about what's being asked. So the goal is always to be able to express position as a function of time, as well as your velocity as a function of time. And if acceleration is also changing or gravitational force is changing as a function of time, you can express that as well. And that will allow you to be able to solve all of these problems. So now let's revise our early. So we have these five equations, right? So we can pick the second one similar to before. So we want to find first position as a function of time, and then we can differentiate that to get velocity, which is number one in this list. So here it says, suppose you throw a ball upwards at 25 meters per second. So that means you have a ball here, and then you're throwing the ball. So ultimately, it reaches a height where it's gonna stop, and then it's gonna come back down, right? So this means you have initial velocity of 25 meters per second square, and it's gonna reach some height here, v final equals 0, and then ultimately it will come down here, right? So that we could call this v final 2, and then this could be final 1, right? This is when it returns. Um, so so the first one is asking how long does it take the ball to get to the top of this height, right? So for this one, you can use the first equation, which is v equals v naught plus gt, right? We know the final velocity, or what we call v final 1, is going to be 0. And then you have initial velocity of 25 meter per second. Apologies here, I put 25 meter per second square minus 10 meter per second square t. And if you rearrange this, it becomes 25 over 10 equals t. So it takes about 2.5 seconds to get to the top. The next question is asking you, how high does the ball go up before it comes back down? So that's asking for this height here, right? So what is this height? Y of t. So here, using the second equation, you can do y of t minus y naught equals v initial t plus 1/2 gt squared. So y naught is 0 because you're starting from the ground. So this becomes yt equals, and then initial is 25 meter per second square plus 1/2 minus 10. Don't forget the sign here, t square, right? This gives us y of t equals 25t minus 5t squared. So now we're able to express the position as a function of time, and this is going to be really useful. So now we're asked how much height has it traveled right before it returns. So we know how long it takes, it 2.5 seconds, right? So we do y t equals 2.5 second is 25 times 2.5 minus 5, 2.5 square, right? So this gives us, I'm gonna do a quick calculation, and this will be 62.5 minus 2.5 square times 5. So that's okay, that's 31.25, right? So if you subtract this, you will get 31.25 meter. So it will have traveled this high with this initial velocity, right? And then third one is, after the ball returns to its original height, what's the speed of the ball when you catch it? So this is asking for final velocity. So again, sorry, let me write down, this is for A, this is for B, right? It's C. So as I said before, we can do by doing derivation of this as a function of time, we can find the velocity equation. So if you do this, it's d dt 25t minus 5t squared, and this becomes 25 minus 10t, right? Okay. So v of t equals 25 minus 10t. right? And as you know, it's gonna take it 2.5 seconds to go up, and it will take it also 2.5 seconds to come down. So we're looking for the velocity at time equals 5 seconds, right? That's the total round trip time. 25 minus 10 times 5, and this gives us negative 25 meter per second. This is the final velocity. And the first one is, how much time does it take for the ball to return to its original height? So this also becomes very simple using that expression for position, right? So this is y of t equals 25t minus 5t squared, right? You can use this expression, or you can just use the original calculation. So this means y of t is 0. It has returned to its original value, 25t minus 5t squared. And this is 5t into t minus 5 equals 0. So that means t equals 0 or t equals 5. So the first time it passed that position was at time t0 when you threw it up. And the next time is at time equals 5 seconds. So this is the end of this question. Thank you.